Alright, so in this video I'm going to go over some ideas of what object-oriented programming is, and then I'm going to make a car class in object-oriented style. So for this since this is C++, this is actually the first kind of lesson I've talked about object-oriented because we start off really with kind of C, and then we move into object-oriented programming later on. So the chapter talks about structs, and I am reading this going, why would anybody ever use a struct? It makes no sense. And then I was reading some online posts, and there's people who are writing messages going, you know, the reason why they did it is it's kind of this in-between thing between C and C++, because the history of C, it was all procedural programming, and then there was this paradigm shift into object-oriented programming, and C++ allowed for the C code to then become object-oriented, and structs were what, you know, were used, I guess, but in a more modern language like Java or Python, they don't have structs, you just have classes. And so I'm not even going to really talk about structs. I'm going to talk about classes and object-oriented programming with that. So alright, so the idea of object-oriented programming is, let's say we have a house. Okay, so a class is like a set of blueprints. Blueprints are not real. They are an idea of something. Okay, and I apologize, my writing's bad. It's not the easiest thing to write out. Okay, so a house could be, let's say, 3 beds, 2 baths. That's it. Let's just say, well, let's say it's 2,000. And that's the most basic blueprint of our house. So here then we can do like, you know, like Jim's house. And Jim's house will inherit all this stuff. But his house will be blue and have a finished basement. And then we could have, I don't know, Ryan's house. And his house can be yellow. And what else? What could he have? He could have like I don't know, he could have like a 3-car garage extension. Okay. And we'll do my house. We'll say Mike's house. And I will have a green. Let's do green. I like the color green. Greenhouse. And it will have, I don't know, let's say I got solar panels on the top. And, you know, like a custom kitchen or something. Ooh, and I'll have a pool too, because I like swimming. Alright, cool. So, notice how all of these houses, the fundamental structure of these houses are the same, but we can kind of semi-customize them with, you know, paint color or just different things. But it doesn't fundamentally change the structure of them, all right? At this level, we have objects. Okay, objects are real. Okay, so anything real is an object, okay? The idea of something is a class. It's a set of blueprints, okay? Now object-oriented you can break the, like, what's hard is figuring out what are going to be the objects and what are going to be the classes, because you could have multiple classes with lots of hierarchy, all right? So let's close this and open up another one and write this out. Let's see here. I might just have to do okay, so cool. So like up here we could have, you know, mammal. And mammals are warm-blooded, feed their young milk, live births. What characterizes a mammal? Like hair? I'm not sure all mammals have hair. I don't know. Because then I can't remember what I know. Aren't all mammals warm-blooded? Let's say they feed their babies milk, and they're live-haired. Like a dolphin is a mammal, but I'm not sure. Do dolphins have hair? I don't know. Okay. Either way, let's say this is our definition. So this would be our superclass. Okay. And then we can break them up into other, like, kind of subclasses. So we could say, like, canine and cats, you know. And they have different features. And then from there we could do, like, specific objects, like, you know, a golden retriever. I think that's spelled right. Okay, and that'd be your object. Okay, and then this is the superclass. This would be your subclass. Okay, and you can get into this thing called inheritance, and that's I think, you know, a subject really for your next higher level programming class. Okay, inheritance. But the idea is that, you know, this class will inherit these things into here, but then there's specific things about canines that separate them from cats, or separate them from, you know, maybe you could have, you know, I don't know. You could think of all the different things in the animal kingdom and then break them up, and then each one would have its own separate object down here. Okay, cats would be, you don't even know the type of cats, like you mean like a lion or something like that. So anyway, the idea of this thing is so that you can, the whole point of this is for code reusability, because in the past with procedural programming, you'd have to write out, for a golden retriever, you'd have to write out it's warm-blooded, it gives its baby's milk, and it's a live birth. But if I do it in a hierarchy like this, I only have to create one mammal class and then inherit it into the canine, and then the golden retriever would inherit the canine class, and so therefore it would inherit everything from its superclasses above it, alright? Okay, so I am going to create I already created another car class, and but I'm going to show you how to do this in object-oriented terms. And it's not a whole lot different than what I've been doing, but so you go in here, you got your car class, main car, you go in here and you right click, and you say add a class. Okay. Class will be called car, and what it's going to do is it's going to create a car.cpp file and a car.h file. Okay, so now let's look at this real quick. I want that open as well. Okay, so we're going to create our H file real quick, alright? So I'm going to say public, and I'm going to demonstrate this first. So I'm going to say string make and this is called an attribute. Okay, string model, same thing, attribute, int year. All right, so I got an error right here. When you're using this and you're doing your .h file, you must include string, okay? And we'll do that. That should fix stuff. All right. I actually didn't include that one time, and it took me forever to figure out. So make sure you do that. Okay. So then right here we'll have our car constructor, and we'll say string x, string y, and int z. Now a constructor, when your object is being created, it's going to call this constructor. Okay. So right here, if I go car, and I'm going to call my car object a BMW, and so the make is going to be called BMW, the model is going to be called an X5, and let's say the year is 2010. Okay. Okay, and I'll create another one called Ford. And I had a 69.5 Mustang, I believe. Yeah, maybe mine was a 67. I had one like right when I graduated high school. I bought one. Bad idea. It was freezing in the winter and hot in the summer. It ran fine for a few years, but it definitely drove. It was not a smooth ride, but it's kind of fun to have. Alright, so notice right here in my car CPP I have this include car.h. Okay. The reason for that is because this is my class, and it's basically like this is so what we've done when I've started here, this up here defines my variables, and then I would up here I would define my methods. It's doing that right here, and then my car CPP just includes it. Okay. Okay. So this is going to. So this kind of defines my constructor and my it declares my variables. But right here I'm gonna write out my constructor. So I'll say car string x, string y, and int z. And I'll say make equals x, model equals y, and what year equals z. Okay, so this these should be, let's see here, car h, public. Model year. Alright. Let's see here. 2 errors. What is it saying? Identify car as undefined. Okay, I gotta include the car.h. So pound include. Alright, so that fixes that. So make sure you include your header file, okay? It should be good now. Okay, so now watch this real quick. So make model year. Alright, so if I do cout, I'll say bmw.make, and then I'll do just a blank space. BMW dot model and BMW dot year, and I'll do the same code right here, only for Ford. Okay, make. All right, let's try this. All right, so that just displays the make, model, and year. But you really don't want to do it like this. And this is kind of like a struct. So let's look. I found. So when you're let's look at this real quick. So this is a class. We've got our X, and we're assuming it's private, okay? Now, it's automatically defined as private unless we do what I've done, because I'm going to show you this happening right here. I made it publicly private. And so if I did t.x equals 20, you'd have a compiler because x is private. You can't access the variable if it's private, okay? Whereas a struct, it's automatically defined as public, and so if you try to access it and assign 20 to x, it works fine because x is public. That's basically the biggest difference I've seen between a struct and a class. And again, I don't understand exactly why a struct even exists in the first place. In a second, I'll explain why. From all my understanding of object-oriented programming, you would never want this to occur. Ideally, what happens is you want to I'm going to go in here and change this, okay? I'm going to copy that, and I'm going to type private, and I'm going to make all these variables private, okay? Ideally, what you want to do is you want your variables to be private and your methods to be public. And the idea of this is something called encapsulation, and it's basically data hiding, and it helps with security. So right here I get an error instantly because I'm trying to access private variables, and I don't want to do that. What I should do is say getmake and create methods that can return them, because the methods are public and the variables would be private. So I would say getmodel and getyear, and I would access them here, and they would still return and display the same thing, but I would be getting them from their public public functions and not their, not accessing the variables. So in here I'd want to say string car, and then I would say getMake, and then I would return the make, string car, what do we got? Get model, return model. What am I doing wrong? It's just because they're not here. Duh. So I could say get make string get make, string get model, int get year. So there I go. I defined my, declared my methods, okay? And then in here I can write them out. So now the errors go int car get year, and then return the year. Okay, so no errors, so declare them here, define them all out, what they're going to do. They're going to return the make, model, and year, and then the errors go away there, and I can run this thing, and okay, should just display the, the different things. So create a BMW object and a Ford object from the car class. Showed you how to create and set up a header and the car class, and then you want to access your variables through the public functions and not through the variables themselves, okay? And that's an idea called encapsulation. So this video is done.